Hello, everyone. Second last for this today, so soon you can rush off. I can see some of you already packed, ready to go. And this talk is about backup and disaster recovery in Hadoop, or I could also have said the lack thereof. So this is a bit of lamenting about what's missing and what you could do to work around the missing bits and pieces. For those who haven't seen my first talk today, I'm with a company called OpenCore. All we do is big data and Hadoop. I personally have, it's my 10th year in Hadoop. I started in 2007 by coincidence and got stuck there somehow, and I'm still loving it, so it's great. And I'm an engineer. I am a Hadoop, HBase committer, but not doing much committing lately because of time constraints. I'm doing mostly consulting. And I've written the HBase book, working on an update. For those, again, who didn't see me this morning, this is the beard. It's like I'm not shaving my beard until this thing is done. I'm working 2 years now on the refresh of this book. Just to give you some context for HBase, this first book was 550 pages. I'm now at 1,250 pages for the second edition. So just giving you some context. Honestly, I don't want to kill you with these pages if you ever read it or so, but that's how complex these systems are these days. And we're working also, I'm working with 3 ex-colleagues from Cloudera, which I worked for before, on another book called Hadoop in the Enterprise. There's really actually 2 books talking about everything like what I'm talking about today will be in that book as well. Right, and here's our contact if you ever need help with Hadoop, let me know. For the context today, it's a really short agenda. We're going to give you some context on backup and disaster recovery, and then I will talk about the various backup strategies that are available, or you could choose to back up data. For context, the first thing is when we talk about sort of backup and disaster recovery, the first we have to settle on the terms. Backup really means that we can take some data, freeze it in time, and then have that ready if ever something happens, say you're losing data or you have to recover some erroneously deleted data, then you can go back to the backup. So it's like what we always had, like the backup on an external hard drive or tapes in the past and for larger systems. Backups help us to freeze some form of state into some media and can recover it from there. And then we have, on the other side, disaster recovery, which means if some disaster strikes, if something happens, we talk about what can happen in Hadoop, then we have the ability to recover from that, and it helps to somehow get business back in, get the company back in business, and trying to sort of minimize the financial loss. Because if you have a disaster recovery, you will say well, come back in 2 weeks, and we say an online shopping site, and we fail for 2 weeks, then that's not what we want, because in 2 weeks' time, no one's coming back to our shopping site. So this has to be somehow related to what your business is, right? And then so your disaster recovery strategy is based on your promise to your customers of what you want to offer them and how fast. Then we have this problem, and this is just one overview of one way of stacking things together in this Hadoop ecosystem. If you go to Hortonworks or other vendors and get a Hadoop, you get a combination of lots of tools, and each of these tools have their own information behind it. It might be data, it might be metadata. And some of them come with simple tools to help you talk to either or, either talk to the data, extract the data, or extract the metadata. Some have that, but not all. So some only have half of it, which means you can extract the data, but you can't get to the metadata. So that you have to figure out each of these tools, and as you can see, there's a lot of them. You have the low-level stuff, the low-level information down here, and then it builds up on top, and all of them may have some information, because if you talk Hadoop now and disaster recovery and backup in Hadoop, then we need to figure out, okay, what do we actually have to include in a backup? And obviously now we're talking about Hadoop, which is this, as I said, on one side it's the big data system of choice. There's no other choice actually. There's the only thing that you can choose these days. There's no commercial alternative to Hadoop. So everyone either runs Hadoop in the cloud or you run it on premise. But Hadoop is sort of the one thing that everyone uses to do big data. And if you actually get into that big data realm, which means you really have a lot of data, how do you back this up efficiently? Is that actually possible or not? So it can be ranging from terabytes of data to multiple petabytes in practice, and how do you, can you actually move this away or not? And then also, if we talk about distributed systems, it's not only a stack of stuff, like a stack of tools, orchestrated carefully so that it works for you and does what you need to do. On the other hand, it's like a whole complex system on its own. It's lots of different servers doing different tasks. Then you have management servers that have separate tasks and do different things. You have the actual worker nodes which hold the data, but also run multiple systems on top of them. So how do you do all of that, right? So the question is, how do you back that up? How often and how? And as I said, just to give you an overview of like the system itself. That's an old slide, ripped from Cloudera, actually, sorry. As I was with Cloudera before, so it doesn't really matter because it's all like the sort of the stack in general. You can see like the core stuff. And if you look at the number of tools that you have, and if you think about each of those may have their own data somewhere. They either have metadata or data, and how do you actually back this up? So this is just showing you how complex this is. And could have a whole different conversation with you another hour or something about that. I think this is madness, but anyhow, we already see that some of these are falling off the bandwagon. We see that major distributions drop some of these tools. So I think there will be some shake up and some, I don't know, unification or some I don't know, simplification going on, but this will take another few years. But it's fairly complex. So why is it really difficult in Hadoop to back all of this stuff up? For starters, at scale, moving data around is nearly not possible. Like moving data for like a couple of petabytes out of a cluster, where do you move it to? Like, do you have a filer? Do you have like a, I don't know, external hard drive with like 1 terabyte? You have like a thousand of them, like a thousand of them, and I don't know, you could try that, but it's probably not very practical. So how you actually do this? And I'm always about like looking at this from the physics way, like what is physically possible, what are the connections of that cluster to other systems. If you have a WAN, like a wide area network, for example, a WAN connection between that cluster and another cluster, and then you're starting a job copying the data across, your backup will be only as fast as that connection is, right? And that connection is, like most of the time, it's shared with other workloads, so this might not be an option. The sheer inertia of that data, just feeling like this big, I think the elephant is actually quite good sort of animal for like the Hadoop ecosystem, because it's just like this big thing and it moves slowly, right? And it's very heavy and you don't want to lift it because it's like, no, that's like way too heavy. You know this, you see it, it's way too heavy. Although with Hadoop being software, a lot of people don't grasp the concept of how heavy it is moving a lot of data around. And if you just do the math, there's some talks about like how quickly you can copy data. You can parallelize some of the tasks, and this is what Hadoop is all about, parallelizing I/O. That then helps you to crunch problems faster. But if you have to like serially read everything, that's this data, and move it out to somewhere else because you have only a bandwidth in between, that might not be possible. If you basically duplicate it, if you possibly duplicate it to another, say another cluster, you can also think about, okay, I already moved this data over. Should I not make use of that there as well? I mean, isn't it useful if I already have that data in another location? Couldn't I use this there as well? Which raises a whole other, or opens a whole other can of worms, but it should be possible. Why not? So if you have multiple clusters, you could actually run different workloads. But how do you then fail over? So that's like one of those questions. Traditional backup tools, and I only know traditional backups tools from like, as I said, I'm from so I went to like college or university in the 90s. So that was like everything was much simpler, and there were like software that you can buy, or like I remember there were companies providing server-side backup tools that probably still exist today, but you never hear about them. And if you went like through the pavilion today and had a look around, what you see ingest companies, services companies, you see BI companies, you see platform companies helping you with lots of things around Hadoop. But tell me how many backup companies you have seen today. I dare you, I guess 0, exactly. Because I haven't seen anyone. These are the typical companies that I see at a lot of conferences. And if you go to quite a few of those, some of them, I feel there's a lack of that, and I don't know exactly why. Well, I know I have an inclination of why, but because it's difficult. Like in Hadoop, backing up data is just difficult. So Hadoop does not really give you the interfaces, for example, to have the standard tools use Hadoop as like a filer or something. You can't really just make this work. There's too much moving data going on, or too much different data going on, too many locations. That does not work well. So that's not really that great. And the included tools are that if you look into Hadoop and you look at the tools that come with Hadoop, there's some help, some indication of how to do that task. But overall, it's not complete, and by far, I would say, rudimentary is a compliment. It's just a bash scripts or so, like so really not that great. So when we look at now the sort of the bigger picture, there are actually tools who use databases as well. I mean, if you install Hadoop and you're like, oh, I have this huge HDFS that can store in it, but what you had to do when you set up Hadoop is you always have to set up a database as well. It's like sort of not the Antichrist, but I'm just saying that we turn to Hadoop sort of tries to replace the databases, but it needs a database to run, right? So that's like well, you can argue that, but we have databases because we need this still for transactionality. We need this because there is metadata in Hadoop that needs to be captured, be it from the manager. Like if you use Ambari, for example, there's a database behind it that stores what you just configured. If you submit an Uzi workflow, that workflow is submitted or is stored in a database so that when Uzi crashes, you can start it somewhere else and it comes back as it should be. That's great. But there are some tools, if you set it up out of the box, if you don't use a distribution, that actually use developer options. So some tools, when you play around with them, use these sort of like embedded databases like a Derby or SQLite that are sometimes just single user, and that is no option anyway. So you should never use any of those developer options, whatever. You typically want to set up a database that is highly available, and I'm trying to push this responsibility out of the Hadoop realm. So I hope you have a chance when you talk about, you talk to your IT team, if you can, have them host the database, because they know databases from like decades. They know how to do this HA, they know how to do this reliably, they know how to like do SQL dumps, save them away somewhere. So if you can at least push this out of that sort of responsibility, then great. But I have seen clusters where the database is part of the Hadoop stack. So the whole Hadoop environment is handled by the same team. And they had to set up their own environments. They have to set up their own high available database. And you spend cycles on like figuring out how to do HA proper on whatever, MariaDB, MySQL, Postgres. And then you still need to make sure that actually that you do the right thing, that actually works. And you can't concentrate on the Hadoop side of things. So if you can, make sure that you talk to someone that can actually take over this task. If not, then you also have to include this into your efforts. And what happens to other stuff that is not part really of that stack that, let's say, the distribution can't point you to? As I said, if you use Hortonworks, for example, HDP, a lot of the tools will be automatically configured to point to like a central like database where you can use it, which you can use as a backend. But you will have tools as well that you install on the stack sooner or later that are not part of that, and make sure that you somehow point them to the same database, well, the same database system. You want to create different databases or different schemas on it, but somehow trying to consolidate this and don't run on 10 different databases just because you can. Then there are two different things, and I just, you know this, I mean, you probably know this already, but there are two different topics that we have to talk about, and I will just explain this briefly because we need this later on. When we talk about backup and disaster recovery, we have two major sort of attributes. One is the recovery point objective, and the other one is the recovery time objective. Recovery point just means when I do a recovery from a backup, how much data have I lost? Right? How much? When I do a daily backup, which I hear this again, I hear this quite often. Oh, this database is fine. We do daily backups. Daily backups on a transactional system? I'm not sure. I mean, if you lose like on the 23rd hour, just at the end of the day, you're losing the whole database. You lost 23 hours of transactions. Not sure if this is a good idea. Then the recovery time objective is how quickly can I restore everything that I need to restore to come back to a productive environment? Like how quickly can I get business back onto its tracks so it can do its job? And again, in Hadoop, this is an interesting question because what do I need to recover? If a lot of you and some of you I recognize, I know you're running Hadoop clusters. if I would ask you, I would put you on the spot and ask you how much you actually have to pull out, what is the vital stuff, you probably would be challenged because you have to think. It doesn't come naturally. You have to like start thinking. So yeah, there's this thing, there's this over here, and this. So that part is something that is not documented well. So these two together just add up on top of each other. So in terms of complexity, RPO and RTO just driving the cost up and driving the complexity up as well usually. All right. So what can happen? The first thing that can happen in a Hadoop is and that's actually, I start from actually the worst to the better ones. So I start at the worst end, so the bad news first. The worst thing is what you can have is a so-called John Wayne. Who knows what the John Wayne is? You know John Wayne, he gets shot and he just slowly dies and he's like, and he gets up again, gets shot again. I guess it's like any show that you watch today, like Iron Fist or something like this. They're all like this. They get punched in the face a half an hour and get up and win at the end. So the John Wayne just means if you have this problem that your node is slowly failing, that's the worst thing that can happen in Hadoop. That can be detected. Hadoop has some facilities in it. Hadoop, if, say, some of the nodes react too slowly, they will be flagged as, they will be blacklisted eventually and taken out of the equation, so taken out of the cluster. So some of the detection works, but for something like, say, HBase again, which is more low latency, a single failing node can actually cause a lot of disruption. It can affect the entire cluster performance, because if you do scans that touch a certain server that needs to serve data and that one is slow, then it can have like an impact on all of the other results. And it's easy. I mean, some could be bugs in the network driver. I've seen this bonding drivers are typical to have issues. Bonding is one of those things that if I hear anything about, something is wrong with our cluster, somehow it's going slow and it was fine before, first thing I say is usually networking or hardware. And I'm usually right, because it's always, if you can't put your finger on it, it's typically like behind the scenes, and networking is quite behind the scenes. Before you see the errors reporting up top at the kernel level, it's usually too late. So some are handled, some are not. Then you have the partial node failure, where you have single redundant components failing. Disk is stopping to work, that's fine. So this is something that Hadoop is built for. If a disk fails, it gets taken out of the equation again. It's just like, it's getting removed. And you can actually hot swap it if the hardware allows it, and then it goes back and joins the collective, and everything is fine. And really the impact should be only that of the capacity of that component that is failing. So if you have the disk drive failing out of 20, only a 20th of that node is affected, that should be true. So that is the other thing. Then you have the actual full node failure. That's when you have a full outage of like a node. That should be should be caught by your monitoring. So you have like Nagios or anything of that sort, Tivoli. They should easily detect this, because if a node is failing, there should be some red lights going on somewhere and telling you that, or the operating team, that something is broken. So that should be handled just okay. And we have one that is more interesting. What happens if we're going to be talking about failure scenarios, network partitioning? When if you have like a complex system, and Hadoop could be thousands of nodes, the largest clusters in existence are, we know again, the companies stopped talking, but we know about Hadoop, for example, 4 years ago. The Facebook and others already talked about 4,000, 5,000 nodes in a single HDFS cluster. So they're probably reaching, or they must have 10,000 nodes today. So 10,000 nodes in a single cluster, you will have failures all the time. So it's just statistics. And node failure could be detected and can be rectified, and the node can be brought back. And again, this is just built in. That is sort of the prime task of Hadoop, is to handle failure at runtime, and you can replace it, bring it back in, that's fine. And for network partitioning, if you have the problem, if that happens, you have groups of servers now ripped apart. So imagine you have a network switch somewhere in between, the switch fails. Now you have, say you have 1,000 nodes, you have 200 nodes on one side and 800 nodes on the other side. Are they both still operational? Can they still decide what's going on? Can they make decisions of what's going on? And imagine that at the same time you have your backup disaster recovery running. what do you do? Is that cluster still operational, or should you then fail over, or fail over to what? Right? So that is one of those things that is difficult to handle, but it's one of those scenarios you have to think about when you do the planning. So for example, having multiple clusters again for backup purposes and DR, you could actually fail over to another one, but you would need another 2,000 nodes. That's okay. Or 1,000 nodes, sorry, 2,000 together. Right? Just have to, someone has to sign off on it. And what happens if they join again? So the failure scenarios, if you look at this, oh, sorry, there's another one. The last one is if you lose the entire data center. What do you do when you lose the entire data center? How do you recover from that? Again, in this case, I think it's fairly clear. If the entire data center is gone, you only have a few choices. Either you're lucky you have that second cluster, or you're unlucky and you have a backup. Well, you're lucky still, you have a backup somewhere outside that cluster if it's completely destroyed. And you're rebuilding a cluster and then replaying the backup. So all of that is, like if you look at this, there's more, I sort of limited it to the list of tools. You need to look at for every single component in Hadoop, you need to look at this and decide what happens, what do you do at that point, right? I can't give you a patent answer on this one. I will lead you towards what can be done to at least ensure that you have data somewhere. How you actually handle this is really up to your environment. Not all Hadoop components have actually persisted data. So some have data that comes in form of transient data. So this is being computed at runtime, which mostly is okay, because if you have transient data, you should be able, or the transient data should be able to rebuild itself, right? The idea is that any system that only has transient data should be able to fail and rebuild. But you have to make sure that this is still true, or try it out. You have to look at everything. Again, you have to look at every single system, figure out what is temporary data or transient data, and if I pull out the temp directory or something, does it still run or not? Then in practice, the number of components that we see completely varies. I've seen customers who just have a cluster with HDFS, Yarn, and maybe run Spark on top. So this is much more easy to handle, because you look at a specific set of features or components that you can talk about and sort of isolate. If you have a cluster which runs all of the distribution, like everything that is inside, then it's much more complicated. So this being able to figure out what you need is important. I highly recommend building an onboarding checklist. An onboarding checklist, you go to every single customer that you onboard onto your cluster, and you ask them, so what do you need? And if they say, well, I need everything, I want to do Hadoop, right? So I want to do, well, at least store data in HDFS, that's fine. Then they say, well, we also want to use HBase. We also want to use Storm and Kafka and Flume, and so this keeps on going like this, right? So they just iterate over the entire shopping list and tell you everything, and that is okay. I mean, if you are in your company, if you provide this as a service to them, and they're allowed to ask for it, that's fine. But for your backup and disaster recovery, that is crucial, because if you just back up HDFS and not say the data that they have in other parts of the system, it may be detrimental to them. Because if something happens and you tell them, we've done the backup, we just backed up your HDFS directory over here, and they say, what about this thing and that thing and this over here? And you didn't know that we're using it. That's bad. So as you have use cases joining the cluster and using services, for starters, I would recommend questioning everything they want to use, why they want to use it. If there's a good reason, okay. If there's not a good reason, then they should not use it. Keeping your job or keeping the job of this easier. And having this list written in stone, like have them sign off on it. So they now say they want to use HDFS and Yarn and HBase. That's all I want to use. And then you have this, you just put it somewhere, you archive this somewhere, and you can say, I know what I need to back up. And this checklist would also ask for the directories they're using, the namespaces they're using, everything that you need to know to back up the data properly. So there should be like a backup and disaster recovery onboarding list or use case onboarding list that has a special section about what is your data, where does it sit in HDFS, how much do you need to be backed up of that one, is this transient or is this something that you don't need, is this important or not? Just because you're onboarding someone who creates a directory in HDFS doesn't mean you have to back up everything he has in HDFS, right? Because there might be something in there that is completely just temporary and can be lost without any problems. So talk to your customers, talk to your users. And then given the RTO and RPO, this can be quite different, right? How long does it take to recompute that derived data? How long does the derived data take? So if you ask them, or if they say we only need the master data, and all of the other data we can recompute in 3 weeks, your RTO is 3 weeks, right, to get back into business. If that data is needed, you need 3 weeks. So you need to make sure that this is understood by everyone, and someone has to sign off, like some manager has to sign off. Someone has to lose their head. You have to make sure that there's a clear, transparent view on what it means if something goes wrong, how quickly you can be back up. Because if you go to your boss at one time, as I said, the thing crashes, and you go there and say, good news, we have a backup. Bad news, it takes us 4 weeks to get back into business. This, they probably have no choice, right? You give them no choice, but it might not be the conversation you want to have. When the contract renewal comes up or so, you might not get it or so. So communicate. The basic rule is the more you have, the more costly and time-consuming it is. Physics, there's no trick. You can always ask and omit parts if this is okay, but as I said, for reals, make sure, yes, this has to be part of it, or this does not have to be part of it. Then you have 2 strategies. There's 2 strategies in Hadoop. One is the replication for different tools. There is a feature called replication. Not all tools have that. Replication here really means you can copy data and modifications of one cluster to another. It's like the venerable rsync problem. Like you can actually have a directory, you can rsync across to another directory, for those who know rsync. But also, again, for those who know rsync, is you can run rsync with an option that it does not delete data that has been deleted locally on the remote system, so that you can keep everything that has once been copied. It's like your backup. You can do the same in HDFS. HDFS has a disk copy tool, which allows you to say, keep everything over there that was deleted locally, just copy the new data over. But what happens is you're creating a big mess of files on the other end that is, like, has old files in it. If you do this, then someone has to figure out what that actually means. So do I want to keep this or not? Snapshots, on the other hand, again, HDFS has a snapshot facility, and also HBase has a snapshot facility. This allows you to say what is currently in the system, take a snapshot, and freeze this at a sort of a point in time backup of the data, and then you can move it away. And this depends now again where you're doing the snapshots. Snapshots on HDFS are not snapshot in HBase. They act completely differently. There's 2 different systems. So in HDFS you have a directory, you can access a snapshot. In HBase you have a snapshot that you can, with system tools, restore or extract to another cluster. So you have to figure out again how you talk to it. And data is local, because snapshots are all, by definition, they're all local for now. You still have to have that step that takes this data and moves it out to another node. Okay. So for the backup typo there, huh? Nice one. Backup. Backup strategies. So for backup, you can store the data in cold media. So that is an option. You can actually just move it out. Does not come with Hadoop, so moving into cold is up to you. You can talk to the data in Hadoop, but moving it into cold media, there is no tool for it. You have to just write a cron job or something like this that takes this data, extracts it, and moves it to a filer. Some of the tools may have some sort of support, but how do you handling versioning? Like if you take a snapshot A, and in a snapshot A2 or like an A10 or something, if you say without a name or without some sort of information, how do you know that what is included? And so how do you catalog the whole thing? How complete is this and how consistent? And the HA and rec awareness on the other end to somehow maybe back data or being considered backup. This is not really a backup. HA and rec awareness allows you to make your cluster resistant to failure, but and make it high available. But this is not a backup strategy. So calling the HDFS trash functionality, like if you delete something in HDFS and calling the trash a backup, is not what you want to do. Like this is has nothing to do with backup. So this stuff here is not really what you can do. And again, you just within just one cluster, anyways, you need to somehow copy that data over to another cluster. Now let's have a look at what types of data we're dealing with. So there's 2 types. There's data, persistent data, and there's metadata. We talked already about the transient data, but you need to really think about where is any of that located, right? How can I access this data? Is it in HDFS? Is it in HBase? If I write a tool that extracts it from HBase, what do I use? If it's in HDFS, which one do I use? If it's in Solar, can I back up? Where do I back it up from? The metadata on top of that is the auxiliary information. It helps you just how you need this data, because without the metadata, often the data makes no sense. For HDFS, it's okay. For HDFS, you could extract the data and have the raw data. But say you want to restore the cluster on another, you want to restore HDFS on another cluster, you need to often have also the description of the original cluster to rebuild some of the services. HBase is an example. If you have HBase on a cluster and you restore it on the other side, there's a lot of information underneath HBase, be it configuration and other things. You need this because if you just restore a default setting on the other side, load your data, you may not get what you want because it doesn't react the same way as the original cluster. So you need often both data and metadata. Both types need to be saved, or Hive schemas, and so on and so forth. So all of this needs to be somehow figured out. And then this is my pet peeve. This is something that a lot of people don't know is often in Hadoop, the snapshots specifically are not consistent. So in itself, they are correct, they are complete, but the included data may not be what you think it is. So for example, for HBase, if you do a snapshot, that snapshot is asynchronous. It runs on all of the servers distributed, which means if you have updates happening in different regions on the same table, and you say snapshot, it could be that the update that you're seeing on this region is applied, but the other one is already frozen in time, which means you're missing some updates over here. And if these updates somehow transactional-like need each other, you may get a snapshot that does not have all the information that you expect it to have. On HDFS, it's a similar thing. If you have open files in HDFS and you take a HDFS snapshots, open files grow until the end of the block. So while you're writing into a file in HDFS and you're taking a snapshot, and the snapshots now you think it's frozen time, that's not true. Any open file grows on you. So if you take the size of the snapshot and while you have files open, that size will change. So you're creating a snapshot where you think HDFS snapshot is, I don't know, a certain size. It could end up being larger than that size and has more data in it than you actually expect. So if you replay any of those, if you restore any of those data sets, what does it mean for you? Like, who's handling that, right? And often what I see is lately is this is being pushed towards the application. So often now we see that the application gets the onus of handling this inconsistent data set. So you do a restore, and the application needs to know what to read and what not to read. No one has done this. 100% of the applications I know of are not designed to handle inconsistent data. They're always written like they're talking to a consistent system, and they're happy with it. As soon as if you were to stop it and freeze it in time, take some data points out and restart it, what happens to your application? And you need to decide this if you want to handle this or if someone else wants to handle this, right? And if you want to handle this, you should better do this more generically, somewhere in the middleware, some sort of layer in between, because otherwise anyone in your organization has to reinvent the wheel and write an application that handles this. Right. The last thing for this part is the validation. So how do you validate data? And yeah, you could restore like the databases. You could make this somehow work for the system databases that you need in the back end, for the metadata mostly in the state. You could restore them. For HDFS, you could use CRCs. So there's a couple of ways of approaching this, but you need to ask again for a more complex system, and HBase again is one of those examples. What does that mean to you, and how can you make sure that what you have there is actually, once you restore it, complete so that you can get back into business? Again, there's no help. It's completely up to you. So far, backup is a combination of already available techniques, or you have to completely do this from scratch. There is some help or not at all. Snapshots are alone offer some local versioning, but only on this local cluster. Replication is a hot mirror, which means you have to be careful with only if you replicate errors, they get also applied on the other side. So erroneous deletions, for example, get replicated. You have to somehow make sure that you handle this. Consistency, you have to question yourself who's handling the consistency of the backup. What is really the RTO and RPO you want to have, and this drives how much you want to actually invest in it. and there doesn't seem to be anything, at least I don't know of anything commercial. So now let's look at the possible options. So the last bit now is the approaches. It's fairly straightforward, so this is like the easiest diagrams you could see today probably. The first one is the cold export. The application writes into the cluster exports to S3 or some storage, whatever it is, some outside storage, and that is fine. Is that true? No, it's not true, see? Time's not up. She said the time is up. Shoot. The second scenario is the replication, where you have this, you're writing again, the application writing into the cluster is replicating to the other cluster. You can see already, now we have two clusters sitting there. So this is like double the cost, right? As opposed to, I have a cluster and some cheaper cloud storage. So cheaper, more expensive. And then we have this one, where you have writing to two different locations, two clusters, so it's the same pricing. And you have one application writing to two, but now the application has to somehow write to two locations and has to decide, when is this done? When can I act this write? Because I have to have two clusters coming back to me telling me this has been done, or I need something else in between who handles this for me. For example, you often see Kafka these days. So when we put this on a chart, and again, this is the cheapest charts today, the way I see this is, still some German here, sorry for that. So it's like you see this is the RPO, it's high, this is low, and this is the RTO, the time, which is low, and this is high. So the lowest RTO and RPO is just 3 when you have two clusters sitting next to each other and the application writes to 2, right? We have questions in a minute. Is something wrong?
No, I'm asking the one more method. What about the stretch cluster?
Let's pick this up in a second because I'm nearly done, and I'll pick up the question. So the cheapest one would be, the most expensive, but the best option for RTO and RPO would be two clusters, and the application writes to both. If you have, on the other side, if you have the number 1, which is the cloud option, your RTO, your time to recovery, is quite high because you have to copy it back into the cluster. And your point is whatever you'll be able to save there. And so usually those are backups that happen like hourly or daily. So this is like every write replicated. This is every couple of minutes or hours writing into the cluster, into the cloud or whatever it is. And this one is where we have these clusters replicating. So whatever the delay is between the two clusters replicating from one to each other, that's our RTO delayed a little bit out from this one. So that is your possible scenarios you can have. And we see in practice mostly, in practice we see all of that. Any of those combinations. I've seen all of that. I also have seen the combination 0, which is no backup at all. So that's option 0 is always an option, right? It's like you just one cluster, rules them all, done. But then as you all have to agree on what that means. But for the actual options, I have seen all of them. Large corporations which sort of go all in Hadoop, often you can find them down here. We know, for example, eBay has 2 700-node clusters. Where they replicate between the two clusters, so we have both available. It allows them, for example, to run statistical jobs on the other cluster. It allows them to update one cluster while they're using the other, then failing, then switching over, then updating the other cluster. So 2 clusters has a lot of nice benefits, but it costs the most. And I've seen the other one with like backing up into the cloud as well. That's like the sort of the easiest solution to get into, but as I said, it's not the most timeliest one, and you have to decide if that's the option that you want or not. Right, and what do you really do? This is my advice, is if you haven't been in Hadoop yet, I'm hoping there's some of you that hasn't done Hadoop yet, but if you ever get into Hadoop, you need to put backup and disaster recovery at phase 1. Like whenever you start planning Hadoop, you need to plan for backup and disaster recovery. And if it's just to say, we don't do it, right? At least be like honest about it and not doing it. But if you want to ever, or if your business ever needs a backup, and I think you may, then you should have this early on in the planning. A POC with a single Hadoop cluster that proves a point is not a production system. It doesn't have backup. It doesn't have all the like the harness and the scaffolding that you need for like actual production. You need to have multiple environments. You need to have a dev environment, test environment, QA environment. You have to have the production environment. You need to have a DR environment, and then you're getting somewhere. You also have to be careful how these systems handle it. To ask your customers what they want, and you know what you need to back up. You may have to push this into the application. That's at least just, make sure that your applications don't need this. And I don't see any commercial offerings that help on this one that are either fully featured. There are few out there, but none of them are really fully featured or do everything. Right. So, question. Well, we have this question first. Sorry.
What about the stretch cluster?
A stretch?
Yeah, having a cluster running across 2 data centers.
Yes. That is a stretch cluster, also having one single HDFS, for example, spanning, that works for some parts of Hadoop, but not for the entire stack. So often this is not an option. I've never, just to technically possible, in practice I've never seen anyone doing this.
Actually, we did it in my company, but it's a small cluster.
Yeah, it's there's a technical possible. I've heard people doing it, but it's not what people do in production or in in larger corporations because it's so hard to handle. Yeah, it's not recommended.
The second and third option, I think if I see the cost-wise, it's almost the same. But you
Yes.
didn't touch upon anything on performance-wise.
Yeah.
If I'm spending the same money, I would like to have a
Yes.
performance impact at least on the better side.
What I didn't mention, so the question was option 2 and 3. Why would I not go for option 3? Right? If it's giving me a much better RTO and RPO, the difference is that I have an option for number 2. I have an option to make the backup cluster smaller. I can make it more storage heavy and fewer CPUs. So I can back up data from one to the other and leave it there. But I can't switch this cluster on for production because it doesn't have the CPUs to do all the processing. Number 3 is the one, typically with a writing to both. Number 3 is usually the one where I have 2 exactly the same clusters, so that both are equally able to take over the load. You still have to decide if you use that backup cluster for other tasks, how you shut that off and move this over to the other one while repairing, right? So, but typically it's a cost thing.
No, I'm talking about performance.
Yeah.
From application perspective, if like it is writing on the 2 clusters, so it means
Yeah.
that he's doing double the job. But yes, you can have it with the Kafka or something, but it
Yeah.
means that I'm putting more pressure on Kafka as well.
Yes.
But on performance-wise, does it the option 2 gives me more benefit or option 3 gives me? Because on the other side, you have
So the difference is if you option 3 means you can decide what goes into each cluster. You can do this in number 2 too as well. So number 2 is where when I said replication, there are different replications as I mentioned earlier. You might have H-based replication, which is nearly instantaneous. But you also may have a H-based replication, which is much slower. So only number 3 gives you the full, just the fast RTO because you have everything current. So it's not the performance thing, it's the RTO on the number 2 is always delayed because some of the tools are much, much slower on the replication end, while writing into 2 clusters from the application side is the actual one where you get both right away.
Yeah.
All right?
Yeah.
Yeah.
Thank you.
One more question?
Do you have experience with
Well, I guess we have to, thank you.